All right, welcome Genesis International College students. So glad you're here. Whether you're literally just starting out or you're already swinging hammers and looking to level up, consider this explainer your ultimate step-by-step guide to crushing Topic 1. We're talking reading and interpreting plans and specifications.
Look, I want to talk straight to you, the future builder. We all know stepping onto a chaotic job site can feel a bit like landing on another planet, where everyone's speaking some secret language. But you don't have to just wing it. Think of this guide as your official survival manual. It's literally the master key to taking raw materials and transforming them into incredible, rock-solid structures.
So, let me ask you this. How do you actually build an entire house from the ground up without making a single massive structural mistake? I mean, how do you avoid total chaos when you've got dozens of different trades all climbing over each other on the same site? Well, the answer is pretty simple. You need a shared secret language, and you absolutely need the ultimate roadmap.
Okay, let's dive right into this. Here's our agenda. First, the builder's roadmap. Second, decoding scale and measurement. Third, the types of construction plans. Fourth, navigating plan features. And finally, understanding job specifications. Let's get to it.
Section 1. The Builder's Roadmap. Topic 1.
Now, to pull off a project exactly the way the client wants it, we basically rely on two core documents, and they go completely hand in hand. On one side, you've got your plans. These are the visual, graphical representations, the drawings that show you what the finished product is going to look like. On the flip side, we have specifications, or specs. If plans show you what to build, the specs are the written rulebook telling you how to build it. The materials, the quality, the whole shebang. You literally can't do the job without both.
Section 2. Decoding scale and measurement. Let's decode these drawings.
Now, obviously, you can't just draw a 20-meter-long house at its actual size on a standard piece of paper, right? But what's really interesting here is the whole concept of a 1-to-1 scale. In your course materials, there's actually a shout-out to this awesome YouTube video by a company called Vision 1. They took a floor plan and digitally projected it right onto the ground at real-world scale, a perfect 1-to-1 ratio. The client could literally walk the halls of their future home before a single brick was even laid. It's just a brilliant way to wrap your head around how scale translates from paper to reality.
For most of your day-to-day work, though, you're going to be dealing with scaled-down drawings. So a 1-to-100 scale simply means that every single unit on your paper is exactly 100 times larger out in the real world. Simple enough, right? But here is a massive pro tip for your career. When you print plans, you absolutely must make sure your printer's shrink or resize settings are totally turned off. If you don't, well, you ruin the original scale, and your measurements will be way off. And nobody wants to be the person who built a room too small for a bed.
Moving on to Section 3. Types of construction plans. Let's talk about working drawings.
It's honestly amazing to see how much this industry has evolved. Years ago, all these technical drawings were painstakingly drafted by hand on these massive sheets of paper with ink and rulers. Today, the vast majority are whipped up using super sophisticated CAD software. You'll likely be out in the mud on a job site, reviewing complex site plans right on a digital tablet. It's a real game changer.
When you're dealing with these plans, you're basically looking at two main categories, and knowing the difference is absolutely crucial. First, you have architectural plans. These are all about the layout, the appearance, how the building functions, basically how it looks and feels for the people living in it. Engineering plans, on the other hand, are the heavy-duty technical docs prepared by structural engineers. They care about one thing: structural integrity. They make sure the building can hold its own weight and won't just blow over in a storm.
But hey, it doesn't stop there. There are plenty of other specific plans you'll need to get comfortable with. Think of this as your mental checklist. You'll see footing and foundation plans, which tell you the exact depth, width, and steel needed in the ground. You'll also deal with framing and bracing schedules. These show you exactly how the timber or steel has to connect so the house doesn't sway under heavy wind. It's like a giant puzzle, and these plans are the solution.
All right, Section 4. Navigating plan features. Time to decode the language.
Okay, every single plan you ever pick up is going to have a title block, usually shoved down in the bottom corner. Treat this like your project dashboard. Before you read a single line or symbol, you check that block. It tells you exactly what the drawing is, the specific scale you're using, the true north point so you know where you are, and most importantly, the revision numbers. Seriously, building a house off an outdated revision number is a classic, and I mean a very expensive rookie mistake. Always check the revision. Now, paper space is tight, so draftsmen use this brilliant shorthand language across all the plans. And this brilliantly illustrates a few common ones. S or SW means a sliding window. SF1, that's strip footing one.
WC is water closet, or, the toilet, and UG is underground. Memorizing these abbreviations is going to be incredibly important, not just for passing your assessment, but literally for surviving day-to-day life on the site.
Finally, Section 5, Understanding Job Specifications. Let's talk about the written rules.
Like we mentioned earlier, specs are the nitty-gritty written details. They're usually broken down section by section based on the trade. So, carpentry, plumbing, tiling, whatever. While the visual drawing might just show a square for a window, the specs will tell you the exact material, the color, and the standard that window needs to meet. They dictate the materials, strict safety codes, state-specific environmental rules, and exactly what level of workmanship is expected from you.
Now, I want to pump the brakes for a second, because this next concept is absolutely foundational. Inside that workmanship section of the specs, you're going to find construction tolerances. Tolerance is basically the strict allowable millimeter variation in a measurement. If your work falls outside that tiny margin, it's non-compliant. You're tearing it down and doing it again. Two massive concepts here are verticality, which is the absolute plumbness or straightness of a wall, and levelness, which tells you the maximum allowable bump in a finished concrete slab. Quality control literally lives and dies right here.
So the crucial point is how all these strict rules come together into what we call nominated locations. These are specific, predetermined coordinates on a plan. And let me be clear, they are not suggestions. They are exact mathematical calculations designed so the plumber's pipes, the sparky's wires, and the carpenter's beams all fit into the same tight space without clashing. If you ignore nominated locations, you're going to have a very bad time. Before you dive headfirst into your formal coursework, I highly recommend looking at the self-reflection assessment checkpoint in your student guide. Before you ever pick up a tool, just take a minute to verify your knowledge. Ask yourself, can you confidently identify those secret symbols? Do you know exactly how to read a scale block? Can you find the specific workmanship tolerances in the written specs?
Listen, by mastering these plans and specs, you aren't just learning how to read a piece of paper. You're learning how to control the chaos, enforce high quality, and bring a massive project to life safely and accurately. So my final question to you today is, are you ready to translate this roadmap into a real-world build? Good luck with your CPCCOM2001 assessment, Genesis students. You've totally got this.